Hi again, guys. Hello, guys. So let's solve this problem. This problem we have to find the reactions. This is a continuous beam. We have 2, 3, 4, 3 equations. So that means that we have one redundant. And I think I presented this case also before by using the force method. I think, I'm not so sure about it. But let's use the slope deflection method for doing this. The first thing that I like to do is finding the fixed end moments, and I like to do that because it's really easy. And, you just finish that and that's it. So what case do we have? We have this case. This is the case that we have. You see, if you look at, no, sorry, yeah, if you look at this, the fixed end moment AB, you assume that it's completely fixed, like that, and this is what we have. So the fixed end moments, and we can start with fixed end moment AB. It's gonna be WL squared divided by 12, and it's gonna be in this direction. This direction. That direction means positive for our convention. Positive. So the fixed end moment AB is going to be equal to 3, the value of the load, times 25 squared divided by 12, and that's gonna be 156.25. Keep perfect. And I said it's gonna be like that, which is positive. Now the fixed end moment for BA, fixed end moment for BA is the same situation, but it's gonna be this one, so it's gonna be negative, like that. So it's going to be negative 156.25. Keep perfect. Now the fixed end moment BC is gonna follow the same equation. So 3 times, but the distance is different. 15 squared divided by 12, and that's going to be 56.25. Once again, positive. Keep it. And the fixed end moment CB is going to be negative 56.25. Keep fit. Also, we know beforehand that the moment at A is 0, and the moment at C, is also 0. We know that because this is a pin and this is a roller. The moment at B, don't confuse the moment at B with the moment provided by the support B. Here we're going to have a moment, and that moment is going to come from the continuity of this beam. So it's something different. Because we're going to be using this type of equation here, like that. This is a pin, and this is a continuous support, meaning we have to use the modified equation. Modified slope deflection equation. What is the modified slope deflection equation? I'm gonna just copy it. I know the moment at A is gonna be 0. I'm not gonna apply any equation for A, but from B, the moment from B towards A is gonna be equal to 3 times EI over L. This is the general equation, times the rotation at B minus 3 times minus this psi, plus the fixed end moment BA minus the fixed end moment AB divided by 2. That's the general equation. If I have to apply for, I'm just changing the marker because this is almost gone. So let's get this thing here. Let me see. For 3 points. Done. 3 points. Okay. So let's apply this to our case. Moment BA is going to be 3 times E times I. But I for this one is 2I. So 2I, this is the value for this inertia in this part, divided by L. L is 25. multiplied by the rotation at B. And remember, what is this? When we were dealing with the derivation or explaining the method of this thing, I went through this and I show you that this value is the angle produced by the displacement of the chord due to a relative displacement between both points. So this displacement for this case doesn't exist, meaning that will be 0 for our case, plus fixed moment BA. Fixed moment BA is negative 156.25 minus fixed moment AB. Fixed moment AB is this one, so 156.25 divided by 2. And believe it or not, these signs, what is happening with these signs here is what people mess up the most when dealing with these signs. So MBA, we have one equation that is going to be equal to 0.24 EI rotation minus 234.375. And we have one equation here. If you want, I'm going to work this problem keeping EI, even though I have the values for EI, but you just can multiply that and keep coherent units. I'm going to do that in next problems so you can see the difference. Some people see it easier keeping it like that. Some people see it easier working in the other way. Okay, now the moment BC. Now what are we doing? We're calculating the moment at this end here from this part, the moment in this part. So let's calculate the moment BC. Moment BC is also a modified equation, continuous here and in that part. So if you apply the modified equation for that, once again the modified equation, and you reproduce the total equation here just for you to remember. And this is the first example. It's the same equation all the time. Now just keep in mind these letters here. The first one is the first one here, and same thing here, and this is the other one. So that's the only thing that you have to keep in mind. So MBC is equal to 3E. In this case, I is just I divided by L. L is 15 multiplied by this plus fixed moment BC is 56.25 minus CB. CB is negative 56.25, so it's minus negative 56.25 divided by 2. And the moment BC is going to be equal to 0.2 EI rotation at B plus 84.375. And we have another equation. Now let's look at these equations. Equation 1 and equation 2. Now if you look at these two equations, we have a system of two equations with how many unknowns? I have 1, 2, and 3. I have three different unknowns. I have MBA, the zeta B, MBC, and zeta B is the same. So 1, 2, 3, but I have two equations. So where is the third equation coming from? The third equation coming from has to come from equilibrium and has to come with compatibility, but now compatibility from the equilibrium point of view, not the displacement point of view. So if you look at, for example, at the support B, we know that at the support B, when you study that, look at what happened here. You're gonna have the support B. I'm gonna make a cut at the support B right here. This is the support B. This is the reaction at B, and then you have the beam on top of that, right? And this is the other support, the support at C. And then here you have the same thing, right? The beam on top of that, and then you have the support over there. This is going to produce a shear here that is going to be transferred to this part, and it's going to be like that. So this is going to be the shear at B transmitted from the left side, and this is the shear at B transmitted from the right side. On top of that, additionally to that, we have the moments. We have a moment here that is going to act like that, for example, and a moment here that is going to be acting like that. This is called the moment BA. This is called the moment BC. So if you just focus on this cut, you don't have to do this every single time. I'm just doing this to explain you what is happening here. If you do summation of moments at B only for the joint, then what you get is that MBA plus MBC, MBA, whatever the direction it is, I don't know the direction. Let's put the same direction. I mean 1, 2, because I'm not so sure what the direction is. But what I know is that the total moment MBA plus the moment MBC has to be 0. The resultant moment here has to be 0. Plain and simple. The support is not going to take moment, so this moment plus this moment here has to be 0. And we're going to use that equation as our third equation to put it together with these two. So let's do that. MBA is this equation, 0.24 EI theta B minus 234.375 plus, remember this is MBA, plus MBC and that has to be 0. And then from here we can solve and get this value. Now if we wanted to just calculate the rotation, that will be the value of the rotation, plug in EI, and that will be it. But this is not our objective. Our objective is calculating the moments, because with the moments we can finish the problem. So what we are doing is in the equation number 1, which is this one, so we can calculate MBA as 0.24 EI multiplied by rotation, which is 150 divided by 0.44 EI minus 234.375, and then we can calculate this and this cancel out, and then we can calculate that moment BA as negative 152.56 cubic feet. And then we can do the same thing for moment BC. But I know the moment BC is going to be, by this equation, just the opposite of this moment. So the moment BC is going to be 152.56 cubic feet. Now we know the moments. How do we proceed and calculate the rest? Well, the way we calculate the rest is just getting these values, and plugging these values into the equation, into the beam. So we can do a detailed analysis of the beam, and we can do something like this. I'm slanting this too much. So let's do, remember our original beam is this one. So I want to cut this in several parts. So what I'm going to do is I'm going to cut it, and cut it there. And what we have is something like that. That will be the span AB. This is 3 cubic feet. The load. And then you're going to have here some shear that is going to be produced here. And then I'm going to call this the shear or the reaction at B to the left of the diagram. And then you're going to put the support remember the support is here, this is going to be the reaction By, but on top of this, this force is going to be transmitted here to the left, and then I go to the other side. The other side is going to be like this, and you can put also here if you want, you can put here this little support. So this is going to be like that, and this is going to be like that again, and this is going to be AY. And when you go to this end, you're going to have the little support here also. So you're going to have this VC, VB to the right, which is going to be transmitted here, VB to the right, and this one here will be transmitted here, which is in turn the reaction in Y. And now we have to complete the moments for all of these things. The moment here I know is 0, the moment here I know is 0. Now the moment in this end, we calculated moment somewhere over the rainbow. Moment BA here, moment BA, negative 152.56. So negative. This is the moment, 152.56, which in turn is going to be transmitted here, like that. Now, in this case, the moment was 152.56, and it was positive. 152.56, and it was positive. So we're gonna put, you don't have to do this analysis every single time. Once again, I'm just doing this to show you how to do that. And that moment will be transmitted here. What is our objective? Calculate the unknowns. What are my unknowns? I mean, for example, this one is unknowns. So I can just do summation of moments. Let's say that I want to calculate the reaction in Y. The reaction in Y is the same value as this one. So if I do summation of moments at this point, at B to the left, like that, or to the left of B, then I can do that, and I can say this distance is 25, this distance is 15. If I do moment here, I'm going to have negative 25 VA, right? Negative 25 VA plus 3 times 25 times 12.5, 3 times 25, 3 times 25 times 12.5, minus 152.56 equals 0, and then VA, which is the same value as the reaction in Y, that's going to be 31.398 kip. Now if I do in this part summation of forces in Y equals 0 on this section, then I get that VA minus 3 times 25 plus VB to the left equals 0. So I can calculate that VB to the left is, this is my calculator. Where are you? Scooby-Doo, where are you? 75 minus 31.398. So that value is going to be 43.602. Now I can repeat the same procedure in the other side. I can do summation of moments at BR, and I'm using this part, this section here, and then you can calculate CY. You can say positive 152.56, this one. I'm doing moment here, remember, positive plus, and this value here, this is 3, so minus 3 times 15, 3 times 15 times 7.5, location, plus 15 BC equals 0, 15 BC equals 0, so BC, which is the same as CY, is 12.3293. Now, if I want to calculate this one, I can do summation of forces in Y equals 0, and then I can say that VBR minus 3 times 15 plus this value, which is BC, and I know has to be 0. So my value for VBR is 3 times 15 minus 12.3293. That's 32.6707 equal VBR. So if I have this value, which is this one, 32.6707, and I know this one, which is 43.602, I can calculate my reaction By as 43.602 plus 32.6707, and my reaction By will be 76.27. And I didn't even need to do this or that, because if I did this and I did that, I could have done in the overall beam, I could have done summation of forces in Y equals 0, and then I can say that VA, which is AY, what is the value here? 31.398 positive minus the total force, which is 3 times 40, plus CY, which is 12.3293, plus BY equals 0, and I can solve in this equation for BY. 31.398 plus 12.3293 minus 3 times 4 is 120. 76.27 is showing negative, but I have to pass it to the other side. Remember that. 76.27 keep, and that will be it. So once you have the reactions, easy peasy, lemon squeezy, shear moment diagram. Come here, go up, come down, go up, come down, go up. That will be the shear moment, the shear diagram. And every time that you have this type of beams, I wasn't planning on doing shear moment diagram, but I want to explain you just this really quick. Every time that you have this type of continuous beam, like that, you have this distributed load, the shear diagram is super easy, the shear moment diagram, because always is going to follow this shape. The shear diagram is going to come like this, like this, like that, like that, like that. And the moment diagram is always going to be like this, like that. This could go higher or lower, could be even positive, depending on how close these spans are, and especially when you have one small span followed by 2 big spans. But you will get a feeling for that later on. Now you want to know how much is that. You know the value of the reaction. The value of that reaction was 31.398. You know the value of this reaction here, and that reaction was 12.3293. And now you need this value here. Well, this value here is going to be this minus 3 times 25, which 3 times 25 minus that, let me show you really quick. 3 times 25 minus 31.398 is 43.602, right? But 43.602 is this value here that we already calculated, so we know this value, 43.602, and we know this value also because that value is this one here to the right, 32.607. Now you want to know how much is this distance? Remember, the value for this distance is this total, 25 times 3 divided by this value, and that will be this one here. So that will be 25 times 3, 75 divided by 31.398. That value should be multiplied by 25 again. Yeah. So in percentage, 25, 25, yeah. The total value here is 3 times 25 is 75, 75, then you have this value. So you can say, what I'm trying to tell you is this, look, you can say the total distance, which is this one, 75, is at 25, as this one, 31.398 is 2x. So basically is the total value of the force. If you realize this is just 3, the value of that. So you can say that the value of x is no other thing than this value divided by this value, 31.398 divided by 3. That value is 10.466, and you can use this for your equation, for your moment. Same thing here, 3, that's the value, right? So it's going to be this divided by 3, 32.607 divided by 3, that's going to be 10.869. That's going to be that value over there. Look how easy this is. I'm not going to tell you that in statics. You have to learn how to do it first. This is 0, this is 0, and then this value here is the moment AB or BC that we calculated before. I mean BA or ABC, BA or BC, and we calculated those values also as, where are you, 152.56. That's it. I forgot, important, very important thing, I didn't say yes. That's really important, don't forget that. Now, this is positive, this is negative. Remember, positive decreasing, even though you don't know that, please don't neglect infants, neglect young people instead. Now this value here, what is this value here? 31.398, the area. 31.398 times 10.466 divided by 2. That should be, what? No, wait. 31.398 times 10.466 divided by 2. That makes more sense. 164.305. Just to be sure, minus 25 minus 10.466 multiplied by 43.602 divided by 2. Perfect, I'm here. And this value here is going to be this value, negative of course, plus this area, plus this area, 32.607 times 10.869 divided by 2. I don't know, let me try again. 32.607 times 10.869 divided by 2. Yep, apparently it is minus 152.56, 24.64. And just for the sake of checking if this is correct, let me subtract this area, which is minus 15 minus that, 15 minus 10.869 times 12.3293 divided by 2, and that's going to be 0, and this is going to be yes. This is an error, of course, but that error comes from this part here. Yes. So that should be the result for that. If I have any error, I mean, I did this really quick, I didn't calculate anything. I don't think I have any error in this part, but you never know, it could be. It could be. Yep, that's about it. If I have any error here, don't go crazy, do it again. I don't think I have any. I don't have the solution for this. I wasn't prepared to show you this. But anyway, now watch the next one, because in the next one I'm going to repeat this, However, I'm going to include settlements also in the supports. Watch the next video. See you soon.